All right, we're going to use a little bit of this inverse trig to derivatives to solve product rules and quotients and chains and stuff. All those things that we start off with, we just continue to use. We just add more tools to our tool belt. Yeah, dude. There's those derivatives we found from before. Make sure you get them on lock. There's only 3 to remember. And then just remember your signs, right? And if I could give you a little bit of emphasis on the ones to memorize. Emphasis. If you're going into Calc 2, gotta know sine inverse. Because we start going back this direction. So you have to be able to recognize it to go back when we start integrating. Kind of the opposite process of a derivative. We go the other direction. And you gotta know tangent inverse of x. There's not much reason to know cosine inverse. I mean, for this you do. Like, we got to be able to use it. We're trying to get you to memorize it. But when you start going the opposite direction at the end of this course in Calc 2, you just don't need really cosine inverse. You don't really need cosecant inverse. You sure as hell don't need cotangent inverse. But there might be an application here or there that I haven't seen. I'm just a math person, so what the hell do I know? All right, let's do a couple problems. And let's just address this right now. Some of the notation sucks in math. It just sucks. Because we look at this, I'm like, hey, dude, you want to do a quotient? Yeah, no. No. Now, watch what's going to happen if we bring this up at the top. And those mean 2 completely different things. Those mean 2 different things. That's where arc cosine might actually be, using the arc instead of that to the negative first power crap we write it as an inverse. That might be superior, you know what I mean? So these are 2 things that mean, there's the same thing that mean 2 different things, just like English. Anybody that learned English as a second language, you're like, this language is stupid. You say the same freaking words and it means 3 different things. Yeah. It's like English. It's all convoluted and stuff. And it depends upon context. Yeah, so this is our outside function. This is just saying, like, you could rewrite it, I guess. I mean, I don't know why I'm in pink. You could rewrite it as arc cosine of x, and it makes it a little easier to see that we're going to do something different. There's no exponent to fall there. So our y prime is going to be, that's going to fall to the front, and we get our -1 in front, and then we have our arc cosine of x, or cosine inverse. So now we need to subtract 1 from and get -2, and now we need to multiply by the derivative of cosine inverse, our arc cosine. Cosine inverse is right there. It's -1 over the square root of 1 minus x squared. So we pop that in. -1 over the square root of 1 minus x squared. The negative 1's clearly cancel out, and you are left with, I'm going to write it, oh yeah, I'm going to get weird with it. So the negative, it's so stupid. It's so stupid the way we're writing that, huh? Wait, is this going to be better? I'm just continuing to go, just to continue to go. Sufficient. But that notation sucks, so just be aware that that could pop up. Alright, just by the way it's written, a negative exponent and the inverse sign can maybe get confused. If you ever feel like you're getting confused, change it to arc. I prefer to write it as cosine inverse, it's just the way my muscle memory works, so I'll continue to do that. But just know that you have this option. So again, I wrote this thing as arc sine of the square root of x. I maybe like this thing better, written as such, sine inverse of the square root of x. Well, we have a product here. So let's break it up into 2 pieces. We have a function here, and we have a function here. So we're going to say, all right, we write our x and its derivative underneath. And now we're going to take our sine inverse, and I'm going to change the sine inverse of, and this is x to the 1/2 power. So our derivative of the outside, now this is where shit's weird. We're going to take a derivative on the outside of sine inverse. So sine inverse of the square root of x. That's all we're taking a derivative on. The outside function becomes 1 over the square root of 1 minus something squared. Holy crap, that inverse function just totally changed. And now what we leave in the parenthesis is what's in the parenthesis up here, that x to the 1/2 power. Now we multiply by the derivative of x to the 1/2 power, and that's 1/2, let me move it over, x to the negative 1/2. But I think this needs to be cleaned up just a tad. Let's bring this 2 to the outside. We get the square root of 1 minus, and this just becomes x. We drop this down to the bottom, and this just becomes the square root of x. Hence, we could maybe say this is 1 over 2 times the square root of x times 1 minus x inside of there. Yeah, I don't know whether that's how far you want to go, but knowing how to reduce it would be good. So it's this times this, and then this times this. So we can say our f prime of x, let's change that to, let's go with this. Yeah, success. F prime of x, we're going to take our x and multiply it by right there. Right there. Actually, I should have left these things two separated. I don't like this step. I don't like that step. Now that I'm seeing it, I'm like, wait a second, that would be better to put it with, because then the x and that square root of x are going to cancel pretty well. So let's write that in. You're going to get x times, and then we put it times 1. Alright, cool. And then we're going to add it to, so if we did those two, now we just got to do, it's just 1 times sine inverse of the square root of x. And I'm going to change that to the square root of x. Let's clean it a little bit. That just becomes the square root of. So what is this? It's the square root of x over 2 times 1 minus the square root of, square root of 1 minus x plus sine inverse of the square root of x. And there is our derivative. Tricky. Chain rules are going to get really freaking weird now when those words turn into an algebra function. You know? When the outside function starts off as a frickin' word, sin, and then the next thing you know, you're writing 1 over the square root of 1 minus whatever was in their frickin' argument squared. It's a lot. Here we go. Here's another chain. Now this one's going to show it a little bit different. So our derivative, I'm going to write what your textbook says, that if y is equal to secant inverse of x, it says that its derivative is equal to 1 over x times the square root of x squared minus 1. There are many texts that disagree with that little statement there, but our textbook says it, so we're going to stay with what our textbook says and not get into it at all. So the derivative of our outside function is going to be what's in blue. So when we go to take our derivative, g prime of x, we actually need to write this in. It's 1 over something. I'm not writing the x's in. I'm just writing parentheses. And there's the beginning. There's the derivative of the outside. Now we're supposed to leave that inside alone. So everywhere you see an x, you've got to leave those x squareds minus 3s. Now we multiply, because now we put it in there. There was the chain. We left the inside alone. We took a derivative on the outside. We left the inside alone, what's in black, and now we need to multiply by the derivative of what's on the inside, that x squared minus 3. That derivative is 2x. And there's not much to clean up here. I think you just move this right here. Put the 2x up top. Circle your answer. I think that's a sufficient answer. Simplified out, I wouldn't mess around with anything down that denominator. I'd just leave that shit sitting there. Yeah. So there would be handling a couple of inverse trigonometric derivatives. Get your practice with it. Yeah, it gets weird. It gets weird, especially with like the multiple x's and words turning into frickin' algebra functions. Get your practice, and I will see you in 3.6. This will be the last kind of large section before your next test. See ya.